Till now we have seen the polar representation, one example for rectangular representation. Now we'll start for how to convert sometimes from polar to rectangular. When there is a need to convert such format, we first see the generalized form of polar to rectangular. If the phasor is given in polar form r angle y, then it can be represented in rectangular form using x and y components. So we can write the values of x, that is r cos phi, and y as r sin phi. So put these two values in the rectangular expression. So putting this value, we get that from the triangle. Let's say this is angle phi, r, x and y. So find out cos of phi. Cos of phi is adjacent side upon hypotenuse side. X divided by r. Cos of phi is x divided by r. We know r is Vm. Now what will be value of x? As x is unknown part, r cos phi or Vm cos phi. Similarly, once again we see for the sinusoid, sine of phi. So sine of phi of this angle is y divided by r. So unknown is y. So find out y. Y is r sin phi or Vm sin phi. Put this value in this equation. So now this was the given form, that is r angle phi. We have found out rectangular form is r cos phi plus j r sin phi. Now similar conversion we could do from rectangular to polar. So you know the rectangular equation. Yes, v of t is equals to x plus jy. Now we want to convert it to this format, that is r angle phi. Put these values of x and y. How we got this value? R square is equal to x square plus y square. Pythagoras theorem. Yes, this is the triangle. X, y and r is the value. By Pythagoras theorem, x square plus y square is r square. So taking under root of both sides, r is under root of x square plus y square, and similarly we could find out angle phi. Angle phi we required, this is phi angle. So tan of phi is y divided by x. So taking tan inverse of both sides, so this bracket has been put on by mistake. So tan phi could be written as tan inverse y by x. So we could write in polar form as under root of x square plus y square tan inverse of y by x. Now why we are learning this rectangular and polar? Sometimes we need to add the phasors. So for addition we use this rectangular format, and for multiplication we use the polar format. So first of all we see addition of two rectangular format. Let us say two signals are there, V1 and V2. So they could be represented in polar form as R1 angle phi 1 and R2 angle phi 2. Now for addition we need not add them in polar. we will add them in rectangular. Now we know how to convert from polar to rectangular. So find out values of v1 and v2 in rectangular format. Yes, r1 cos phi 1 plus j r1 sin phi 1. So here we could write as x1 plus j y2. Now x represents the real part and j, that is imaginary part. So while similarly we could write v2 also. v2 is r2 cos phi 2 plus j r2 sin phi 2. So put this in rectangular form, that is x2 plus j y2. Add signal v1 and v2. So we have these two brackets. Uh, this this is real part x1 and x2. Add them and addition of imaginary part will be done over. So we will get the final answer as x1 plus x2 and the imaginary part y1 plus y2. Similarly, in subtraction, two signals could be subtracted. So real part will be subtracted from real part. So x1 minus x2, as minus sign is outside the bracket, so take j common, y1 minus y2. So these are the both equations of addition and subtraction.